Welcome to Lesson 5 of Module 2 on Introduction to Databases and Database Management Systems. I am going to start with a personal question that I want you to think about throughout this lesson. What database transactions have you made today? You have 3 objectives in this lesson today. You should be able to provide an example of a transaction that you have made recently. In this example, you should briefly explain the key characteristics of database transactions. I want you to explain the meaning of the word transparency for transaction processing services. Transaction processing has strong analogy to production management. Whereas production management involves the control of physical goods, transaction management involves the control of information goods. Transaction management, like management of physical goods, is enormously important to modern organizations. Organizations such as banks with automatic tellers, airlines with online reservation systems, and universities with online registration could not function without reliable and efficient transaction processing. Large organizations now conduct thousands of transactions per minute. With continued growth in electronic commerce and mobile computing, the importance of transaction processing will continue to increase. In common discourse, a transaction is interaction among 2 or more parties for the conduct of business, such as buying a car from a dealership. Database transactions have a more precise meaning, however. A database transaction involves a collection of operations that must be reliably processed as one unit of work. So transactions are all or nothing, meaning that all operations of a transaction must either succeed or the entire transaction is canceled. Transactions should be processed reliably so that there is no loss of data due to interference among concurrent users operating at the same time, and failures such as operating system crashes. The requirement for no loss of data adds overhead, but this requirement is crucial for the success of organizations. Now let's look at some pseudocode for an airline transaction. This code indicates the data requested from a user, such as flight preferences, and the interaction with the database, such as updating a flight record. Making an airline reservation typically involves reservations for the departure and return. To a traveler, the combination of the departure and the return is a transaction, not the departure and the return separately. If a departure and return were considered separately, a traveler may make a departure without obtaining a desired return flight. In the pseudocode example, you should note that the multiple database operations are necessary. 2 update operations for the departure and return records, and 1 insert operation for the reservation record are necessary. You should also note the exception handling indicated by the line with on error. If any kind of error occurs, such as loss of connection, any partial actions are removed with a rollback statement. After the commit executes, all actions are recorded in a database without interference from multiple users and loss of data from failures. For a second example, let's consider an ATM transaction. These transactions have been common since the early 1970s during the early days of database management software and database development. The structure of the ATM transaction is similar to the airline reservation example. The ATM transaction example shows data requested from the user, such as account number and transaction type. Multiple database actions occur, such as posting a debit and corresponding credit to the bank's accounts. If failure occurs before the transaction terminates, all actions are removed or undone with the on error and rollback line. Database management systems provide 2 services to ensure reliable transaction processing. DBMSs ensure that concurrent users, that is, users operating at the same time, do not overwrite each other or cancel each other's actions. Without proper control, work can be lost as one concurrent user overwrites another concurrent user. DBMSs also ensure that a failure after a transaction finishes will not result in loss of data. 2 internal features of a DBMS provide these services: concurrency control for controlling actions of concurrent users, and the recovery manager for dealing with failures such as communication errors and software crashes. It is important to note that these services are internal and transparent to the database developers. In common usage, transparency means that you can see through an object, rendering its inner details invisible. For DBMSs, transparency means that the inner details of transaction services are invisible. Transparency is very important because services that ensure reliable processing are really difficult to implement. By providing these services, DBMS has improved the productivity of database developers because database developers do not need to write any code to use these services. However, these services have overhead that may require more resources, such as servers, disks, and memory. This lesson has introduced the ideas of transactions and transaction processing. Transactions are units of information work that must be processed together. DBMS provides services that ensure reliable transaction processing with no data losses from concurrent users and failures after completion. Transaction processing requirements and DBMS capabilities continue to evolve even after 50 years since the introduction of ATMs and early transaction processing software. One of the recent areas of DBMS development has been methods to reduce overhead for greater demands of electronic commerce and mobile computing. Now let me return to the question I posed in the beginning of this lesson. Can you identify a database transaction that you have performed and indicate the types of information you provided and the actions made on the database to complete the transaction?